0.4, okay, plus by, okay, dy is going to induce a positive rotation about the moment. So it is 1.5 plus a 3 is 5.5. So 0.55. The whole thing is equal to 0. So dy is equal to 0.4 times 10 to the power of 3 plus 0.15 times 10 to the power of 3 is equal to 5500 divided by 0.55. So dy is 550 divided by 0.55 is equal to 10 times 10 to the power of 3 Newton. Okay, then it's the same, right? So you same summation about forces in the y direction is equal to 0. So you have ay minus 10 times 10 to the power of 3 minus 10 times 10 to the power of 3 plus by 10 times 10 to the power of 3 is equal to 0. So ay is also equal to 10 times 10 to the power of 3 Newton. Okay, so you get the same answer. Okay, if so now we have to calculate the moment. Okay, we have to calculate. So remember, earlier we said that we can treat it like half a cantilever beam. So we just draw this out. Okay. So we know that this is our point A. We know that this is our point B. And we know that failure is going to occur at point E, right? So this over here is 10 times 10 to the power of 3 Newton. At point B, it's going to do this, right? And then we know that our moment, so we're going to assume, okay, we're going to assume that the moment, which direction we're going to assume, hold on, I forgot anti-clockwise. Where is it? When I was proving the cantilever beam concept. Yeah. Can't remember now. Sorry. I want to, yeah, it's anti-clockwise, okay. So this is your moment at point E. Okay. So the distance from here to here is 0.15. And the distance from here to here is so it's 250 divided by 2 is 0.125. Okay. So from here you want to find moment at point E. Okay, so we're going to do summation about moment in the z direction at point E. The whole thing is equal to 0. Okay. So the first one is going the first at point A is going in a clockwise direction, so minus 10 times 10 to the power of 3 multiplied by a distance of 0.15 plus by 0.125. Okay. So over here means we are taking the moment at point E where the failure will occur. Then plus the 10 kilonewton is going anti-clockwise at point EB, and then the distance is 0.125. Okay, then you plus by moment at point E, the whole thing is equal to what? 0. Okay, so 0.15 plus by 0.125 times by 10 to the power of 3, so it's equal to 2,750. So minus 2750. Let me do this again. 0.15 plus 0.125 times 10 to the power of 3, 27. Then plus by 0.125 times 10 to the power of 3 is equal to 1250. So this one is moment about point E is equal to 0. So moment about point E is equal to 2750 minus 1250 is equal to 1500 Newton meter. And because it's positive, right? This direction is valid. Okay, so we know that it is going in this direction. When it's going in this direction, the top will be under compression, the bottom is under tensile. And that we know already, isn't it? Based on deformation. Based on deformation, the top is compression, the bottom is under tension. Okay, so that part is done. So if we look at the formula, what do we have now? So the formula that we're going to apply, we have found what is our MZ. Why it depends on the distance, we don't know yet, because we don't know the centroid yet. Okay, so down here we don't know the centroid position, right? And we don't know our IZZ yet. Okay, so two more things to find. Okay, so I'm going to copy the diagram. Okay, so probably you guys have seen this figure before. It was used in your term test, I think. Okay, so I'm going to find our centroid, and so I'm going to write this way. Okay, so this is our 1, 2, and 3. Okay, so I'm going to take datum from bottom. Okay, so I'm going to do this. You guys probably are very familiar with this already. So datum, so find centroid and IZZ. Okay, so we have section. Now for this case, we cannot find the centroid just by observation. Okay, you have to really calculate 1, 2, and 3. That's the first thing that we do. Then you have your width and depth. So like what I told you, we know that this is our width, and over here this is our depth. Okay, so for section number 1, the width is 10, the depth is 60. Okay, so just to confirm, width is 10, 60 is correct. So this is equal to 600. For section 3, the width is 30, the depth is 10. So this is equal to 300. So 663, so this is 1500. Okay. Then the next one, because of how we divide our structure, the Y bar is equal to 60 divided by 2, 30. This is also 60 divided by 2, 30. And this is 10 divided by 2, it's equal to 5. Okay. So what I've done down here is the datum. Okay, I use the datum at the bottom, and then finally we calculate the MD Y bar or omega or with that Y bar. So it's 600 times 30 is 18,000. 18,000 for 1, 18,000 for 2, and then the next one is 300 times 5 is 1,500. So 18000 times 2 plus 1500 is equal to 37500. Let me do it again. 18000 times 2 plus y 150. Yep, 37. So we have our Y bar now is equal to 37500 divided by 1500. Yeah, 37. So it's 25 millimeters from the bottom. Then we find our I1 is equal to I2. Okay, so this is 10, 60 cubed over 12 plus by 600 multiplied by 25 minus by 30 squared. Okay, so this will be equal to 10 times by 60 power 3 divided by 12 plus 600 times by 25 minus 30 close bracket squared is equal to 195 times 10 to the power 3 millimeter 4. Okay, and I'm applying exactly how I taught you guys. Okay, I'm not looking at anything. I'm just looking at the table, just forming the equation. Okay, it's mindless work. That's why I can talk to you like that and still write. Okay. So 30 times 10 power 3 divided by 12 plus 300 times by 25 minus 5 close bracket squared. So it's 122.5 millimeter 4. Okay. So now we can find our I total is equal to 2 I1s plus by I3, right? So this is 195 power 3 times 2 plus a 122.5 power 3 is 512. So I write down here. So this is twice of 195 times 10 to the power 3 plus by 122.5 times 10 to the power 3. I get 512.5 times 10 to the power 3 millimeter 4. So this is 512.5 times 10 to the power minus 9 meter 4. Okay, so that is the second moment of area. So now we are almost done. Yes. Okay. So we found our second moment of area. Okay. So we know that the top is under compression, the bottom is under tension. Okay. So again, I'm going to copy this diagram. Okay. So now we are going to, so I'm going to call this point I, and we're going to call this point J. Okay. Or alpha, beta, whatever. So we're going to find stress X at point I, right? And we know that it's going to be compression, right? So minus the moment we found is what? The moment that we found was 1500. The y distance, so we know the centroid is 25, right? We know the centroid from the bottom is 25, right? We know that this is 25. So I is 60, right? So 60 times 10 to the power minus 3 minus by 25 times 10 to the power minus 3. Because it's relative from the what? The y distance is relative from the centroid, not from your datum, okay? And then from here, you divide by 512.5. Is it 512? Yep, 512.5. So this will be equal to 60 power minus 3 minus 25 power minus 3 times by 1500 divided by 512.5 power minus 9. So I get 102.439 minus 102.439, okay, times 10 to the power 6 Pascal. Okay. So now we're going to find at point J. Okay, so stress X at point J is equal. So we know at point J is going to be tensile, right? So that's why we put 1500 without a minus. And then the distance from the centroid is 25 times 10 to the power minus 3. Now divide by 512.5 times 10 to the power minus 9. So this will become 1500 times 25 power minus 3 divided by 512.5 power minus 9. So it's equal to positive 73.171 times 10 to the power 6 Pascal. Okay, so this is done. So now, as I said, I'm going to do a step further. We are going to sketch this out. Okay, we're going to sketch this out. So I'm going to sketch and label, because in the term test you'll be asked to sketch and label. Okay. So our x-axis will be our stress. So our stress value range from 63 to, so I'm going to do by 120. So minus 120, 100, 80, 60, 40, 20, 0, 20, 40, 60, 80. Okay, so this is our normal stress in the x direction. And on the y direction, we know that the centroid is at 25, yes or no? Right? So we all just need to do from here to here. So this is minus 20, minus 40. So this is the y direction. This is 20, 40, 60. Okay. So we know for the top at point I is on compression. Is at 102.439. So it's about somewhere around here. And the distance from the centroid, so 60 minus 25 is 35. Okay, so you draw 35. Okay, so 35. So this is 30, 35. So somewhere around here. Right. So you label this point. Okay, you label this point as 102 minus 102.439 minus 102.439, and then this is 35. Right? How we get 35 is 60 minus 25. You get 35. Okay, and then the other point is at minus 25, and the stress is at where is at 73. Okay, so 70. So I'm just adding more. So this is where we get our 73 point what 171.